knows a lot about the science stuff. Professor Dave explains.
We just learned quite a bit about fingerprint detection using a variety of techniques. Now let's dive into the messy, frustrating, and oddly satisfying world of fingerprint detection on more challenging surfaces. Wet stuff, sticky stuff, squishy stuff, basically anything that laughs in the face of traditional fingerprint powder. If you are daunted by porous versus non-porous surfaces, get ready, as it gets much trickier than that. Imagine the following: a murder weapon tossed into a pond, a beer bottle left in a puddle, or a car door handle slick with morning dew. Traditional powders won't work here, they'll just clump up, but what may surprise you is that wet surfaces aren't hopeless, you just need to outsmart the water. First, dry the surface gently. Blow drying on low heat or patting with a lint-free cloth works, but if you rush it, you'll destroy the print. Once it's dry, standard powders might still fail if the water washed away oils and amino acids. Then we move to small particle reagent, or SPR. SPR is a suspension of tiny particles, like molybdenum disulfide, in a detergent solution. Spray or pour it on, and the particles cling to the fatty residues left behind, even if the surface was soaked. Rinse carefully, and the guilty print appears like a grudging confession. For non-porous wet surfaces, like glass or plastic, cyanoacrylate fuming still works. Superglue fumes polymerize with fingerprint residue even if the surface is damp. Just fume it inside a chamber with a humidity control setting. The fumes latch onto the print, creating a white crust that's liftable with tape. You may have seen it in movies, detectives lifting prints off a corpse's neck, but in reality, human skin is the worst. It's porous, oily, and alive until it isn't. Prints on skin fade extremely quickly, but sometimes you get lucky. Iodine fuming is often the first thing to try. Iodine vapors bond with lipids in the print, staining it yellow-brown. The downside is that it's temporary. Snap a photo fast or spray on a starch solution to fix it purple. For fresher prints, like with cases involving a chokehold, RTX or reflective ultraviolet imaging system can sometimes visualize residues without chemicals. Shine UV light and sweat components might glow, but success rates are quite low. Next up, duct tape, packaging tape, and other such adhesives are where fingerprints go to hide. The sticky side clings to ridges and valleys, making powders useless. But one technique that can be used here is called gentian violet. This purple dye stains the adhesive's sticky side, ignoring the non-sticky parts. Soak the tape in a gentian violet solution, rinse, and the print glares back like a neon sign. Alternatively, sticky side powder, which is a mix of lycopodium and carbon, when sprinkled over the adhesive, creates contrast. The powder sticks to the non-sticky areas, leaving the print visible. Or go with cyanoacrylate plus dye stain. Fume the tape with superglue, then dunk it in a rhodamine solution. Under UV light, the print fluoresces. Now we get to substrates where blood is involved. First and foremost, blood is a double-edged sword. It's great because it's free DNA, but it's terrible because blood is the print. You're not detecting oils, you're enhancing what's already there. For fresh blood, amido black is your friend. This dye bonds with proteins in blood, turning prints dark blue. Spray it on, rinse gently, and suddenly that smudge becomes a detailed map of ridges. For older, dried blood, leucocrystal violet, or LCV, works well. It reacts with hemoglobin, creating a purple stain. But LCV is carcinogenic, so handle it with care. Fluorescent dyes like acid yellow 7 take it up a notch. Apply the dye, shine blue-green light, and the print glows bright like an LED screen. Some other miscellaneous tricky surfaces and their corresponding detection techniques are vacuum metal deposition. For plastics or bags, this method involves vaporizing gold or zinc in a vacuum chamber. The metal coats the surface, but skips the fingerprint ridges, creating a negative image. It's expensive, but can resurrect prints that are surprisingly old. Digital imaging spectroscopy. Shoot multiple photos under different wavelengths. Software combines them, teasing out prints hidden under blood, ink, or odd stains. Nanoparticle suspensions. These are tiny particles, like quantum dots, engineered to bind with specific fingerprint chemicals. Spray them on, and even a 10-year-old print on a greasy engine part lights up unmistakably. As we now understand, every surface demands a strategy. Start with non-destructive techniques like ALS and photography, then escalate. Reversibility matters. Once you douse a bloody knife in amido black, there's no undo button. And always, always document first. Snap photos under normal light, UV, IR. Sometimes the ridge detail pops only in post-processing, so next time you're staring at a waterlogged gun or a piece of tape that's seen too much, remember, fingerprints are stubborn, but science is even more so. Now we move on to the courtroom.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.